Hello. So our last topic to discuss today is not that extensive as parametric tests. Mostly because non-parametric tests are not that popular, so we will concentrate only on two of the most frequently used non-parametric tests. So we will start with the Wilcoxon rank sum test. So if we assume that x and y stand for the randomly selected values from two independent populations, null hypothesis of the test will state that the probability of x being greater than y is equal to the probability of y being greater than x. So this is the way in which we compare those two populations. As you remember, t-test works based on the comparison of mean values. ANOVA is based on the comparison of variances. And Wilcoxon rank sum test is based on assessing the probability that randomly pulled value from one sample is equal to the randomly pulled value from the other sample. So you can perform this test in Gretel. So for this purpose we will use the same data set, although it would be more convenient to use ordinal data. So tools, non-parametric tests, and we would like to analyze Wilcoxon rank sum test with showing details. So this test works through assigning each value a rank, and then test statistics is computed based on the comparison of those ranks. So in our case, p-value of one-tailed test is relatively high, and the same can be concluded about p-value of two-tailed test. So as you remember before, when we compared GDP in 2019 and GDP in 2020 using t-test and ANOVA, those parametric tests actually produced very similar results. So at least at this point, the result of parametric and non-parametric tests are consistent. In both cases, we failed to reject zero hypothesis under two-tailed test as well as under one-tailed test. Another popular non-parametric test is Wilcoxon sign rank test. So null hypothesis of the test is that population mean ranks are identical. So actually this test is frequently viewed as the non-parametric substitute for t-test, which, as you remember, is based on some very restrictive assumptions. We need to have continuous data, we need to have normally distributed data, and so on. So you can also perform this test in Gretel, tools, non-parametric tests, this time Wilcoxon sign rank test. I would like to see some details. So this is the output of this test. We assess the difference between GDP in 2019 and GDP in 2020 as before. And our p-value for one-tailed test is high enough in order to fail to reject zero hypothesis, and the same can be concluded about two-tailed test p-value. So as for now, all of the tests produced generally consistent results. So you might think that that might be not that significant difference between using parametric and non-parametric tests, which is actually not true. So I would like to reinforce that if you use ordinal data, then by default it would be a better idea to use non-parametric tests. Because, as I mentioned before, parametric tests require continuous and normally distributed variables. So non-parametric tests are as far as I remember, not that frequently used in econometric analysis. Usually they are used in sciences such as clinical sciences, psychology, ethnography, and so on. So when you do not have that big sample and when you have no certainty that data is normally distributed and sample is a representative sample, so that's why, as I said, we will not concentrate on those tests that much. They are not that relevant to econometrics. Okay, so thank you a lot for your attention. I really hope you enjoyed this video, and see you in the next one.